The rise in cancer rates worldwide is absolutely frightening. I think it's very legitimate to call it an epidemic. The statistics are sobering. The World Health Organization estimated that in 2020, worldwide, there was about 18.1 million new cases of cancer, whereas in 2022, just 2 years later, it's gone from 18.1 million up to nearly 20 million. And in fact, according to the World Health Organization, if this trend continues, by 2050, worldwide, there's going to be 33 to 35 million new cases of cancer, truly an epidemic and truly a real major health issue affecting every single person everywhere in the world. So yes, that's a huge problem.
For a long time, cancer was considered a disease of old age, the result of accumulated DNA mutations, weakened immunity, and years of exposure to carcinogens. But today, because of nanoplastic exposure, mutations can begin to build up in the body at much earlier stages of life.
There's an increased rate of cancer worldwide in children and also in people much younger than I used to see. So what's going on now is that we're having a rise in people getting cancer, children, young adults, and it's probably not due to smoking or alcohol or anything. There seems to be something else, something in the environment that is causing this cancer at an alarming rate, and it's getting worse. So a very serious problem, yes. And again, one of the possibilities that could be accounting for this, we'll be talking more about it, is indeed nanoplastics.
We observe in the last 30 years that in some countries we observe early onset cancerogenesis, so that tumors are diagnosed more early than previously. So that was like colorectal cancer observed earlier and diagnosed earlier than 30 years ago in average.
A key role in tumor development may be played by mitochondrial dysfunction, caused by exposure to nanoplastics. This happens through the accumulation of mutations in mitochondrial DNA and the disruption of normal cell death mechanisms, which together reduce the body's ability to eliminate damaged cells and increase the likelihood of these cells transforming into tumor cells.
So these tumor cells are very aggressive, and normally they don't take anything up which they cannot use. So, I mean, what could happen? I mean, this is hypothetically that they can produce some energy out of these plastics, or somehow some pathways are activated which are helping, the cells to move faster. That could be. So we need to investigate that. So it's a very important question, and we are basically on that to find out what happens mechanistically in those cells, that they can use plastics to facilitate their mitochondrial potential.
Nanoplastics increase levels of reactive oxygen species in organ cells and tissues, causing oxidative stress that accelerates the growth of cancer cells, helps them spread to other tissues, stimulates formation of new blood vessels, enhances inflammation, and weakens the immune system. Moreover, the high level of oxidative stress caused by electrostatically charged nanoplastics promotes the survival of tumor cells and reduces their sensitivity to therapy, making malignant cells more aggressive.
Anything that damages the normal cell DNA that is responsible for the growth and division of cells, that damage can contribute to that cell becoming malignant, growing and dividing and spreading uncontrollably. That's what cancer is. And that is certainly a concern about the effect of nanoplastics. And then above and beyond that, because nanoplastics affect so much of the cell's function, the oxygenation, the ability of a cell to function, above and beyond that, I'm concerned as a doctor that treats cancer that nanoplastics may be reducing the effectiveness of our cancer treatments. I'm a physician that treats cancer with radiation therapy, so I am concerned about nanoparticles adversely affecting the use of radiation therapy to control cancer. And there's actually been some preclinical research on this that does suggest that the nanoparticles, and certainly contributed to by the typical negative charge that they have, in addition to adversely affecting cells, can actually reduce the effectiveness of radiation therapy. There's certainly a significant theoretical reason to believe that the nanoparticles may reduce the effectiveness of cancer treatments, not only my modality of radiation therapy, but certainly I have the same concern about it reducing the effectiveness of chemotherapy or other systemic treatments or immunotherapy.
Research by the Medical University of Vienna has shown that micro and nanoplastic particles remain inside cells far longer than previously believed, as they are passed on to newly formed cells during division. In addition, there are also early indications that these plastic particles may play a role in tumor metastasis.
So that's one of the problems, that the tumor grows very quickly and then also disseminates. And what we observed is that these particles are kept by the cells even after cell division, and then they are helping the cells to migrate quicker, so they can move quicker. And that's a property which we also observe in tumor cells when they are in the body, so that they can move to other places and even metastasize. And so we have to assume that also in the body, that these tumor cells can basically use those plastics to proliferate and move around in the body. When I came to this plastic topic, I thought myself, that this is, we introduce here material which is potentially toxic, potentially accumulating over the years, over the decades of the centuries, so maybe for a very long time, affecting our health, but also the evolution. I not only mean the cancer evolution of how cancers originate, but even the evolution of new species and the evolution of the whole ecosystems.
Nanoplastics affect every system in the human body. They act as a trigger, setting off a cascade of processes that lead to serious illnesses, all because of their electrical charge. Today, we know that nanoplastics play a significant role in the development of conditions that have become the leading causes of death worldwide.
Life begins with an impulse. Every thought, every movement, every feeling is a flash of electrical signal. But there is an enemy that can destroy these natural mechanisms. It acts quietly, imperceptibly, and inexorably, destroying us from within.
We're talking about microplastics, tiny particles that can't be seen with the naked eye. They're much thinner than a human hair, extremely fine.
Not just a pollutant, not just a toxin. It is a material that destroys the language of life itself. But how does it do this? Once the impulse is disrupted, reality begins to distort. Plastic particles break the connection between cells. They trigger self-destruction programs. They deprive cells of energy.
And it is frightening to understand, and increasingly so with increasing scientific studies, that nanoparticles nanoplastics, as they get in, are actually damaging the mitochondria, that energy-producing part of the cell.
Nanoplastic continuously drains our power from within. Our future has already changed. We just haven't realized it yet.
From the molecular level to the scale of entire ecosystems, understanding microplastics is crucial for protecting the biosphere and public health.
Are you ready to find out what is happening to your body right now? Watch the documentary, Nanoplastics, Threat to Life.